guys, this is the lesson video for 3B, and on this video I'm going to be going through the notes examples for example 5, 6, and 7 on our unit 3 notes, okay? So for example number 5, what we're learning is that we can simplify radicals that also have variables, all right? And this is what that looks like. So for example number 5, we are asked to simplify 42 x squared y z cubed. So you can see from this example that we have a number part, that's our 42, okay? And then we have a variable part. And we want to put the whole term in prime factors, okay? So in order to do that, we're going to go ahead and just start making a factor tree for the number part first. And when we do that, what we're going to see is that we have the prime factors for 42 are 2, 3, and 7. So we don't have any matches that can break out, okay? So we can't simplify 42 at all. But let's see what happens with our variables. When we write this as in its prime factors, we're going to get 2 times 3 times 7, and now let's stretch out those variables. So we know x squared is the same as x times x. We just have an exponent of 1 on our y, so just the one y. Z cubed means z times z times z, right? The same number of our that our exponent is the number of times we're multiplying z by itself. So when we put example number 5 in prime factors, that's what it looks like, okay? And we know that we have an invisible index of 2 there, right? We don't see it, but we know our index is 2. So we know that we're looking for matches of 2 to see what can break out. We have x, a pair of x's and a pair of z's. But all of the rest of our terms are by themselves, and they have to stay inside, okay? Only our match terms can bust out of jail, as it were, okay? So let's see what it looks like. Remember, everything multiplies on the inside. When they bust out, there's 2 on the inside, 1 on the outside, and everything's multiplying. So we'll have an x on the outside multiplying a z. Okay, this is multiply, right? And then on the inside, we'll have that 2 times 3 times 7. That's our 42 when we multiply those terms. We'll have 1 of the y's multiplying 1z. So when we simplify this radical, we'll get xz times the root of 42 yz, okay? So it's a little different. You'll get used to it. Let's take a look at example number 6, okay? So when we're looking at example number 6, again, we're going to notice that we've got a negative term. And that is very important to notice, because whenever we have a negative term inside a square root, it needs to come out as I. So let's go ahead and look at example number 6, which is negative 144 x y squared, okay? So, of course, the first thing we're going to do is we're going to bring that negative out as I, and then we're not going to forget about our I, okay? Okay, now what we're going to notice is that we've got a perfect square here. And any time you have a perfect square, you don't need to go all primes, okay? You can just go right to the factors for that perfect square. And that's one of the reasons why it's a really good idea to memorize all of your perfect squares, at least through 12. Okay, because 144, when you see that, you can recognize that as 12 times 12, okay? Those two numbers are not prime, but it's an exact matched pair that we can bust out, okay? Now, if you did this the way we did the other examples, all the way down to the primes, you would get the same answer. But knowing 144 is a perfect square root, that we can factor that to 12 times 12 will just save you some time, okay? Now we're gonna stretch out our variables, okay? So we'll have 12 times 12 times x times, and we have an exponent of 2 on the y. That means we have 2 y's multiplying on the inside, just one of the x's, okay? And we didn't forget about our I term. And since we have an invisible index of 2, okay, when we don't see a number outside our radical, we know our index is 2, okay? That means we need to have matches of 2 in order to break anything out of our radical. Okay, we're multiplying on the inside. When they break out, okay, from our radical, there's 2 on the inside, but always 1 on the outside, and it will multiply on the outside, just like we're multiplying on the inside. So we'll have a 12 that breaks out, we'll have a y that breaks out. That's going to be multiplying our I. Okay, but we didn't have a match for our x, and so it stays behind in our radical. And our answer for example number 6 is 12y times I times the square root of x. Okay? So let's do our last example, example number 7 on your notes. Now, on example number 7, we've got a new variable. We haven't seen this variable much. On example number 7, we have the square root of 48 k to the 9th power, okay? And even though that's a really big exponent, we do it just the same way, okay? So we're gonna use that number part, okay, and factor that into its primes. So we'll go 2 times 24 for our first branch, 2 times 12 for our second branch, 2 times 6 for our third branch, and then 2 times 3. And that means when we list this in its prime factor form, it looks like when it's broken up into its prime factors, we have 2 times 2 times 2 times 2 times 2 times 3, and then we have 9 k's, okay? And you can write those all out, right, if you want, all the way out, so you have 9. Or you can recognize that you would be able to have lots of, we have 4 pairs of 2, and then 1 k that wouldn't have a buddy. So here's our first k, okay, and we're gonna write them all out after that. So k times k times k times k, and we'll go ahead and we'll make 9 total. And I kind of went down to another row here so it would stay on our screen, right? So one of our k's doesn't have a buddy, but we've got lots of k's that do have buddies. And we've got 2's that have buddies. But left behind, we have 1 3 and 1 k. So you can see how, if you're very careful, it's really easy to find those matches of 2. So for each set of 2 on the inside, we'll have 1 on the outside, and everything will be multiplying when it busts out. So we'll have a 2 on the outside times another 2 times one of the k's, 2 on the inside, 1 on the outside, times another k, times k, times k. So we had 4 sets of 2. That means we've got 4 on the outside. On the inside, we'll have a 3 multiplying a k. And to get our answer, we have to multiply everything back. So 2 times 2 is 4. K times k times k times k is going to be k to the 4th power, right? And then we'll multiply that on the inside, which will be 3 times k on the inside. So long as you're careful when you're stretching out those variables, it'll be really easy to find matches of 2, break them out of your radical, and then you'll remultiply everything back together. So there's our answer on example number 7 for 3B. All right, thanks for watching, guys.